How's it going, everyone? Welcome to another video. Enterprise UI development. Here we are again. So in today's video, we're gonna take a look now at the unit testing model as a way to get a hand practice or to get our hands dirty when it comes to not only understand this unit testing, why we're doing unit testings, how to write unit testings, but also the greatest hits when you need to write your tests, as well as what are the most common functions or the greatest hits when you expect to check that a function work as expected. And then the asynchronous part, and that is how you can now actually, when you have to define your set of functions or your setup for your tests, especially when you need to handle these async operations, promise or timers, and when you want to deal with that, and what are the use case to do that. So this course is taught by Steve Kinney, head front-end engineer at Temporal, where he now previously worked at other companies like Twilio and that kind of thing. And remember that the end of the goal of this particular course is that based on Steve Kinney experience, see how can we actually learn how to build and maintain large code bases over the long period of time with a wide range of contributors in large teams. So first things first, we need to look at what maintainability means in terms of software, okay? And that is perhaps going a little bit in the philosophical aspect of what is maintainability and what do you going. So for example, when you want to maintain, let's say your motorcycle if you have one, or a bike, or your cell phone, or your kitchen clean, okay? Each one of those you want is to preserve, you want to preserve and make that state adaptable, so make that durable, sustainable over time. In the context of software, well, things are a little bit specific. So pretty much like you define some sort of systems that allow you, or some sort of infrastructure that allow you to now is work towards that particular goal, which is maintainability. Let's say you want to do that to keep your body fit. One, also you want is to, let's say, keep you in the gym. So you want to have now a system that provide you the best nutrients to keep up the pace and to maintain that particular fitness, similar to what are the series of exercise that I need to do at the gym, as well as what are the sleep protocols or sleep system that I need to do as well, and so on and so forth. This is just only to talk about in the sense of maintaining your body, okay? Physical body. You can go also to the spiritual body, that kind of thing, you know? But here we're talking is about what are the things that you need to do, what are the systems, what is the infrastructure, what is the basic installation that you need to guarantee that operations, and in this case, for that outcome. And in the context of code, the subtle difference here is that you have now different systems, okay, that you need to do, or a different infrastructure that allows is the or these basic installations needed for maintain this code for it is economy, for it is judicious use of resources. So on that, okay, and because in this course, we're gonna see how to set up the infrastructure needed to build is this long-term needed to maintain these large code bases with wide support contributors in large teams, because we need to actually understand all of this particular terminology, okay, and also describe what maintainability means in the context of code. All right, if you're gonna real life example of that in the fitness, and I'm going to use a lot of fitness exercise, so bear with me. So for example, hey, what maintainability means for your physical body, for example, right? It's like, hey, that I can now show off my body, not only flexing, but also is to feel myself comfortable, that I can do stuff for myself, for my own. So this is part of the things, this is the aim goal for maintenance, okay? Or this is the couple questions for maintaining your physical body. It's like, hey, can I do things for my own? If I want to do a hard task, let's say lifting something, can I do that without compromise myself, without the fear of breaking something? Okay, and this is pretty much in the software, right? There's a good analogy there. It's like, hey, can we now add something to the, so can we do something with the software? Not only add features, but can we now can we be confident when we change something, okay? Or do a refactoring or a update dependency without fear, okay? So all of these things is just what we're gonna cover here by understanding what is the infrastructure needed to do those kind of things. There's 4 things. Hey, can I add something to the code base, or change, or update, or refactor, right? These 4 type of actions that we can do to our code. So to do that, we need to look at, well, what are these basic installation, what are the infrastructure needed, what are the ingredients to make that happen, to make that maintainability, these 4 actions, make that happen. And that is understanding and lay out the systems. So the systems is describe what it is, what it does towards a goal, all right? And the systems for this maintainability. And then I dive deep into, for example, other applications like Java, for example, when you have to do this kind of things. But in the context here of these web applications or UI web development, it's pretty much like, well, you're gonna have a testing system. You also need a build system, as well as an static analysis. Again, this is just the basics. Now we're talking is more specific about what are the things, not that esoteric or philosophical. Okay, so now be a little bit more concrete. From those abstractions, something that is more practical. And then on top of that, we need to know is what are the process, how to do the things that we're gonna do. Okay, and this is, well, we need some code review. We also need some document design, as well as blueprints. And on top of that, once we are doing these things, the know-how, the process, we're gonna encounter things along the way. Some problems, or repeated things that happen, some common problems that happen, and then we have now some solutions to do, some patterns to deal with. So we have now the architecture. So any time we're going to now design is a testing system. Well, this is the particular pattern that we're gonna use. This is the architecture that we're gonna do. This is how we're gonna organize our or files. All right. When we have now a build system, hey, this is the way how we're gonna organize that. Pretty much like the static analysis. Hey, this is how we're going to now run that static analysis. Hey, this is how we're gonna do the code review, or this is how we're gonna do design the document, and this is the blueprint, right? But it all starts with the basics, which is something that we look at this. We all start with the basics, okay? So, because this thing is quite self-explanatory in terms of what we're gonna do now that we have this concrete experience, here we're gonna use this now, of course, TypeScript, GitHub Actions, and a more practical approach of what you're going to really find out in your what you really find out there in the work, not philosophical questions. So we're gonna talk about is practicality and reality. So what are the things that you're gonna find there, okay? And well, the tools that we're gonna use for setting up this UI, the enterprise UI development, which is starting with React. You can shift that to whatever framework that you see fit. So React, we have Beat, which is this next front-end generation tooling that allows us to actually this particular systems that we mentioned here. So for example, like testing and build the systems as well as static analysis, is provide that out of the box. It's already cover that for us. So as I mentioned, React, TypeScript, Vite, which is now used behind the scenes, Jest, which is a JavaScript testing framework that has a lot of resemblance of JavaScript or Java testing environment, such as GUnit, okay? And now in the case of Java, you have things like Maven, which is a build system. This is not specific to JavaScript applications. This is for UI development as well. So this is quite interesting, okay? And the other tools is using now Playwright, okay? As well as testing library for doing something called component libraries. And what we really care about in today's video is see how we can a more practical approach of this unit test. So for that, we need to understand what is the spectrum of testing. Okay, remember that this is one of the systems that allow us to do that. That we set up as a way to make our code maintainable, as a way to make the code work as expected. So we look at the testing. So we have units, we have end-to-end. So unit is just testing that a function actually do what it's supposed to do. End-to-end is now in terms of UX, that the UX actually do what it's supposed to do. It is expensive because you don't own the infrastructure. A lot of the time you don't own several of these infrastructure in that. And most of the time this kind of test is the users being hammering your app, being hostile to your app. And then you have is now integration testing, which is what we're going to actually do in real life sometimes, which is close to end-to-end. The idea here is, well, testing multiple units, integration testing. And then we have something called the component testing, which is now guaranteed that a particular UI component work as expected. And also, we need to understand some of the jargon used in the testing system. So you have now assertions, pretty self-explanatory. This is what you expect after you check that. So you got assertion. So it's an expected value that you want to get once you run a particular test. Your test, which is the code that you indicate what this test is all about. Your test suite, which is a pretentious way of for JavaScript to say, hey, this is a multiple test unit, or it's a multiple test that run your code. So either one of them fails or pass, and that's when you have now test runner to actually verify that all of these tests actually do what it's supposed to. And that slowly but progressively lead us to the component and the integration testing, as I mentioned before, and that leads us to actually understand now finally what we need to do and how we can do for that, right? So in this case, it's like, well, we first look at what are the things that we need to do, or what are the common things that we need to do when we write our tests. We can use it or test, especially because since we're using is by test, it is pretty straightforward because it's more explicit rather than implicit, which is something that I really love about that. You can also run a test by saying, hey, run this test if fails. Okay, so if this test fails, okay, that's a success. The absence of a test is a success as well. And then some other things like skip if and run if that can be useful when you run your tests on Node servers. Okay, so with that, because this particular section's focus is on how you can use Vite, what are the benefits of it, how you can write unit tests, understanding some advanced techniques to do that, which is one of the things what I'm doing here. Okay, understand this particular technique. So we're going to then use some build systems like GitHub, that where we're going to put all of these tests, where we're going to deploy. Not sure if the word deploy it is what you mentioned, but then we're going to our first foray to set up our build process for the affirmation tests to make sure that everything works as expected. So this is just a way of starting to get real feedback of what are we doing and what we need to do here. So first we look at these getting examples as a way to make sense of this. The also is the VTest UI, where now VTest allows, the reason of using VTest is because it's way much more faster since it is running since it was written in Go, and now provide more ESM support. Also, it's come with Jest, so making your Jest migrations to VTest is simple, quite simple. You can also enable is the global for that, which is something that you're gonna do a lot of the time when you import it or when you do this migrations to using VTest. It improved the error reporting because now, for example, the view UI you can see is the model graph, and you can now have a more visualization of what's going on, as well as a flexible configuration. So this is something interesting, good. And for a more practical aspect, is especially when you're going to write your JavaScript application, you need to know is several concepts here, like referential equity, shallow equity, and deep equity, as well as value equity. So referential equity is that, hey, I'm going to compare is now these two objects if they're point to the same reference in memory. Okay, so for example, to be that method that say, hey, I expect these two objects to be the same in memory. All right, to be actually guarantee you that. The other is to equal. I expect now the values here are the same, and also it does this deep deep equality, where this is shallow equality doing recursively, or in other words is that the list of property here, so it's gonna check if the list of property are the same that it is value when comparing these two objects. So this is just slowly but progressive. See how we can start in to have an approach of what are the things that we're most likely to do, and then the greatest hits. So for example, to be close to, which is useful when you want to do some numeric or floating points, because well, in JavaScript actually floating points, for example 0.2 plus 0.3 is in fact 0.1 plus 0.2 is actually doing this floating points operations, and this is something interesting because you can take a look now at the 0.2 plus 0.1, okay, and I think that it is floating point math. Right, this is a website that actually explains you why it's not the same. Your language isn't broken, it's doing floating point math, and computers can only natively store integer, so they need some way to represent decimal numbers. They need a way to represent decimal number, and because they're storing is integers, okay, this representation is not perfectly accurate. So now is a design flaw for ourselves. You know, here's when you started to see the design, here's when you why is more than ever, why is so relevant the designers here, because even if your model is flawed, for example, if you're using the mutation event, okay, they deprecate it because their design is flawed. What is the mutation events? This is a way of how you can now keep track of elements, how you can keep track of don't know elements on the browser or on the DOM. But again, the way the conception, the design was initially flawed, okay, and they have a particular article of doing that. DOM mutations event replacement, the story so far, existing point of consensus. And that is where they describe this one thing, right? So you can go down, and diff is verbose, far too often, slow because of events propagation and because they prevent certain UI runtime optimizations and crashing. So that's what happened here. When you're now used to be close for this 0.1 plus 0.2, it's not that your language is broken, it's that is the representation of integers is not perfectly accurate, which means that this is why more often than not 0.1 plus 0.2 is different from 0.3. It is actually rather interesting. So when you have a base 10 system like ours, it can only express fractions that use a prime factor of that base. And when you talk about a prime factor like this, prime factorization. Oh, okay. Okay, factor prime. So it's when you divide that particular number for another, it will give you it will give you an entire number, or it will give you an entire yeah, it will give you an integer or an entire number. Okay, the prime factor of tens are 2. Oh, exactly, the prime factor of tens are 2 and 5. So we have 1/2, 1/4, 1/5, 1/8, and 1/10 can all be expressed cleanly because their denominators all use prime factors of 10. This is quite interesting. Prime factors. In contrast, 1.3, 1.6, and 1.7, 1.9 are all repeating decimal because the denominator using use a prime factor of 3 or 7. What does it mean is that these prime factors, this is quite interesting. This 0.1 and 0.2 is this. So the TLDR is that in binary or base 2, the only prime factor is 2. And when we talk about prime factors here, that's actually quite interesting. No, but this is prime factorization. Prime factor. Prime factorization. No, but we're talking about its prime factors. Prime number. Translate it into English? Or prime number? Oh, okay. Prime number, prime factor. Okay. Prime in composite. Okay. It's a natural number. It's a natural number greater than 1 that is not a product of two smaller natural numbers. That is not a product of two natural numbers. So this particular prime factor, which is not a number, okay, that is a number that is not a product of two smaller numbers, okay, which is itself. It's the way how they describe this. For example, 5 is prime because the only ways of writing as it is a product of 1.5 and 5.1 involve itself. However, 4 is composite because it is a product of 2 times 2, which is both numbers that are smaller than 4. So the whole point of this prime number okay, is that when we talk about prime factors, which we talk about is small numbers that can, small number, a natural number that is not prime is called composite, but it's say they are greater than 1, and that is not a product of two smaller natural numbers. So a prime number or the prime factors are numbers which they are numbers. Interesting. They are numbers that their product is not okay. They are numbers greater than 1 that their products are not part or that the product that is not a product of two smaller numbers. So you can multiply that smaller number to actually get that. Because of that, and because now in binary logic or base 2 numeric representations, the only prime factor is 2. So as you can see, there is no way to actually get that number because this is base 2. Alright? So there is no way of how you can represent that number with there is no way that you can represent that number. So when you multiply smaller numbers, you get that. So even though you can do this 1 times 1 and it won't give you 2, and that's the only number that you can, and the other number that you can use here in 2 is 0. 0 times 0 is 0, and 1 times 1 is 1. There is no way of how you can represent these 2. So you can only clearly express fractions whose denominator has only 2 as a prime factors. So in binary is 1.5, 1.4, 1.8 will all be expressed cleanly as decimal. Exactly, because they are not because they are not prime factors. While 1.5 and 1.10 will be repeated decimal. So 1.1 and 1.2, which is 1/10 and 1/5, while clean decimal in a base 10 system, are repeating decimals in the base system the computer use. And that's something quite interesting because it's about representation. So 0.1, 0.2, while clean decimal in a base 10 system or repeated decimal in the base 2 system, the computer use. So when you perform math on this repeating decimal, you end up with a leftover which carry over what you convert the computer based binary here numbers into a more human readable base 10 representation. Below are some of the examples of sending 0.1 plus 0.2 to standard output in a variety of language. The TLDR of this, and I think this is why interesting to actually do this, is because since we are looking at the most common or the greatest hits when using assertions, when check the correctness of a particular function, okay? To be, we know what it does. To equal as well. To close to is actually verify floating operations. So 0.1, 0.2, it of course gives you this 0.000003, but it's because the way of how now it treating is the floating points, and especially is the prime factors, because prime factors is a number that is not a product of smaller numbers, natural numbers. So for example, you can now what in the base decimal point, you have now you have now is 3, 5, and 7. All right, so those are numbers that cannot be obtained by multiplying smaller numbers, and in the context, which of course produce is decimals, in the context of binary, because the prime number, the only so 2 is the only prime number. Okay, so when we need to represent is this decimal divisions, for example, one in a base system. So in a base system of 2, all right. So in binary, 1.5, 1.4, 1.8 will all express cleanly, okay, which is no decimal, okay. Exactly, will be explicit. Exactly, will be cleanly explicit with decimal, okay. Whereas 1/5 and 1/10 will give you is now is repeated decimals. So when you are adding is 1.1, which is 1/10, and 1.5, while clean decimal in a base 10 system, in a binary systems, the computer represent that as repeated decimals. So what they're doing is now they shrink that, and I think this is something that is go beyond the language. And this is also something that you're gonna see a lot of the time, especially when you're doing this kind of things. So okay, so we look at that, right? To be close, to be instance of. This is actually have now a function constructor allow the prototype change. To be undefined, to contain. This is quite interesting because to contain check if that particular element is present on the array. So giving a particular invites. Okay, to contain one like so, and to contain, that's right. So assert if an actual value is in the array. Okay. So you can also use that as for document query selector. Remember that this actually return is an element. Okay. Expect element class list for that, because this is not a particular property. You can get that when you're gonna have a list of classes, and I want you to check if they contain is the flex, right? An element is inside another one. There you got it. Expect document to query selector wrapper as it is, right? Hey, I expect that in this element that I'm gonna get, that element actually contains that element. Okay, the element that I'm getting for. Exactly in this query selector, which is interesting. This is an element. Query selector. But query selector doesn't return is exactly. It returns you an element. It returns you is an element for that. Mm-hmm. Interesting. Exactly. Return you an element. Element is inside another one. But this shouldn't be part of the children? So for example, if I say is document get exactly query element query selector, okay, exactly. So I'm getting is this. I contains all of these elements, and it doing this. So now it's doing is this. So I'm talking to the DOM. It's like say, hey, please provide, please listen to query if this element actually exists based on the CSS selectors. So behind the scenes, what it's doing is to actually traverse the DOM, the query selector, and find the first element that it find out. So it actually do this breadth first, breadth, depth, deep first search, pre-order. So you're going from the left, right, and then the node, right? So this is pre-order, and subsequent element or subsequent query are actually hashed by this for the browser. So this contains this browsing mechanism. So far so good. Okay, so things started to make a lot of sense here. And this is quite interesting because it's like to contain, and the type is as a string and then an awaitable. Exactly, to contain assertion if an actual value is an array. To contain can also check whether a string is a substring of another string. Since vtest 1 0, if you're running tests in a browser-like environment, this assertion can also check if a class contained in a class list or elements inside of another element. In vtest 1. That's what I say. What in the F? How can you do this, bro? It's like, for real? It's because the test environment or this front-end tooling. Okay. So to contain, it's quite interesting, right? Quite interesting. Very, very interesting. To contain, to throw, and to throw error. So here we look at a simple example of how can we actually write our tests, and especially how you can put this to do as a way to say, hey, I'm gonna do that. Please, I'm gonna do this at some point, but I don't want you to implement that right now. Okay, that test. This can be something useful when it comes to if you are feel or tired. You can actually put that for reasons. Okay, you can put that for reasons, and yeah, that's quite interesting. That's actually totally quite interesting. So this is this example, right? To do. And alright. So to do is actually, instead of triggering is that you tell the environments that, hey, I want to skip this for a moment. Okay. Part of the anatomy of our tests when we write them is that we're going to have the setup function. This is also come from Unit, this Java testing framework. When they develop now this discipline of how you should test, or how you should write your test. Okay, so you're going to define the setup functionality there. Here in the code, in this testing code, repeating code is much more readable than not. So it's actually quite annoying to actually go to another files or to actually scroll down about what this actually test is doing. It's like it's not great for readability and to actually write the test, because quite honestly nobody likes to actually, or I will argue that nobody likes to actually write tests because it's not that often, it's not that useful or productive. But in any case, and you may wonder, why do we do this? As a way to guarantee that this particular, as part of the correctness of the code. So that's why you want to, when you write your unit tests, write that for that match the story, that actually fulfill the user story. Hey, as a user, I want you to now have the ability to add items here, right? And then you define is now your setup, then the text execution, so what are you gonna do inside of that, and last but not least is the assertion, right? So when writing tests, code repetition is good to keep everything at a glance. Period. We say key features. Is this one. So actually, let's go into, well, let's go into now run some tests or write some tests. That's what we are here.
We're going to do an exercise, and that one is inside of, I believe, Great Expectations. There's some bonuses and some other like fun stuff you can.
Yep. There are also other ones like to match. Okay. There are also other ones like to match, as well as a way to, hey, I want you to now check if that particular string actually contains or match this, similar to match objects. Okay, this is some of the useful things. Exactly. Key features when writing code, or you say is write unit test key features, right? Exactly. Unit test key feature is that. Because here you talk about is now some interesting topic here. Some very interesting topic. Yeah, and they constantly are refreshing that token, and I get it, bro.
There's like a middle ground, which just to kind of show, I will use this half-done asynchronous function to just.
Oh, actually, let me continue to write our test here. Okay. So here we're looking is now at the advance of this. In fact, let me see. That's right. Here we are. Describe person. It will do exactly. So we'll create a person with a first name, which is this. Okay. So the idea here is verify that the person's first name is correct. Okay. So we can remove this expect has assertion. We define the setup because now we already while define the setup. Actually, we write our test execution. So here what we're gonna see is I want you to now or expect first. It's going to remove this, and then it will create a person with a first name. Okay, this is also something interesting as you can get yourself familiar of how you can write your tests, right? Especially text. Here should not include bogus, should include bogus. Let me actually see what's going on exactly. Should low filters, that kind of things. Similar for this. Describe your actions. Describe your actions reducer. Open up job drawer. Close. To actually work as expected. Interesting. In DND, we define is now for any context. Use dispatch DND. It should initialize. It should initialize correctly. Should handle drag start correctly. As you can see, is defining is the setup functionality here. Okay, the setup. Well, actually they define this like so. Alright, but it's important to actually have a particular order to do that. But I think this is the setup. Okay, then the test, the functionality, followed by the expectation here, or the assertion. Should handle drag and when active is null. Should handle drag and for sorting forward within the same driver. What you're doing is actually is defining some tests. Defining some tests. Spy on. Set query that is spy. Okay. So what you're doing is that now you are defining is your test that covers those particular use cases. Should handle dragging for sorting or within the same driver but without order change. Exactly. That's what you're doing. When you're gonna write your tests is based on user stories. Based on that particular story. It's like, hey, now can we actually is make sure that this work as expected? Yeah, it is. That's interesting. That's very, very interesting. Not bug fixes at all. You can also have perhaps some bug fix for regressions as a way to know that you actually solve that. Okay. That's quite interesting. Yep. As a way to know that you actually solve that, which is great. Okay, and then we have now here assigned jobs like this. Hey, this is a lot of things that you can do. Should render driver's row. Should render driver's jobs. Okay. And they expect wrapper mock, virtuoso mock content provider, and that kind of thing. assign jobs, cancel jobs, day picker, driver rows, but all of these are open drivers row menu, but all of these are for renders driver row, expect screen get by test ID to be visible. So all of this, what it's doing is that in this particular code base that actually you're not looking at, but the idea here is to cover is user use cases. That's what you want to do. It's like cover use cases. Period, man. Period. So we're gonna cover those use cases when we write our tests following this particular pattern. The setup, what it is, the setup, the test, as well as the assertion. So here we'll create a person with a first name. So it's going to expect now that we get from that vid. So expect that this new person that we create, since we want us to check that particular object contains that value, okay, what we can take a look is to say, hey, we can say is to match object, okay, all right. This to match object say is like assert if an object match a subset of properties, which is great. Hey, if this match a subset of properties, so we here say expect to match object, okay, used to check that a JavaScript object match a subset of property of an object. Okay, this is one, but this is to match is a subset of property of an object. Optionally, you can provide an object to use a genetic type for the expected value. This ensures that the matching object matches the structure of the provide object-like structure. Okay, to match. Oh, you can even do this. That's great. They provide TypeScript support to match object, house, standard house, kitchen, that area. We're in that. And okay. So to match objects, all right. You can say, hey, to match object of a person, but because we want is to now is provides a partial, okay, which is put all of the, this is part of the TypeScript utility. Hey, put all of these keys as required, as optional, okay. And then I want to say, hey, I want to check if now this contain is the first name exactly as Madonna, right? So when we run this particular test, we got it. We say, hey, CD source samples. I want to now run this in a binary sense, npmx here by saying, hey, yeah, by saying is I want you to now run the test, okay, and run the okay, great expectation. Okay, let me actually get in there. See the great expectations, and now I want to actually run the v-test. Try the test here, the exercise dot test as it is. and then he say, hey, I skip one. Okay, I skip one. And if you want to see if you actually are running is the proper one, I want you to now look at the UI exercise. Okay, and when you take a look now at the use person, he should create an instance of a person. That particular test passed. Right? That's great. Kanban person will create a person with a first name. That's what it is. Exactly. This is the Kanban board, right? Okay. So this is describe create person, Kanban board, person. It will create a person with a first name like this. This is quite interesting, by the way. This is very, very interesting. And I love to combine now TypeScript, which is they show the intents of the code, which is great. Yeah, completely. It to do. All right. Then let's go to now actually verify the other tests here. So for example, of the person, we'll create a person with the first and last name. Okay, Madonna Ciccone. If you take a look now, is this? It's gonna parse that. Okay, this is a function constructor from the class. As you can see, there you got it. This is the function constructor. Type args is equal to a string. If it is, let's go to now parse that. I think this is perhaps some of the inner or private methods here. Parse that, which is say, hey, this is a full string. If the full string does not exist, throw full name cannot be empty string. First name and the rest of parameter, you're gonna split by that. Exactly. And then that'll be the last name. The middle name. Okay, where you say, hey, is the rest length, or if you have any length there. That's right. What you're gonna do is to say, well, I want you to now is get the middle name. Right, because what you did here is just to remove is the last name for that and get the middle name as it is, and it's going to return you correctly is first, middle, and last name, which is something that is going to be used when it parses that. So it received that, then it's going to parse that, it's going to compute, transform that, which is doing some computations behind the scenes. Where you're now gonna get is this one, right? So you got get full name, add friends, and remove friends. This is the property that you can have access to. The getters, the setters, as well as this. Okay, so let's get into this. Let's get into. We actually get is the correct. Correct is this. So what we're gonna do is after you create that, behind the scenes you're doing a lot of this parsing. So this person that must contain is the last name. Okay, we're gonna do is, well, let's go to expect from the person that we create to match. Okay, we can say, hey, instead of doing that, say person dot last name, assuming that we create that last name, okay, to be exactly the last name. I want you to be in terms of reference, or to equal in terms of values, to equal. All right, to the, let's go to, 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 let ABC cone, right? And if you run this, and that test actually passed as expected. If I say this, oh, because I put that, I tell it to skip that. Now it will of course throw an error and say, hey, this is not equal of what I expected. So are you sure it's this one? And I tell him yes, it is what I expected. So good. The other is to do, we'll create a person with a first, middle, and last name, which is great. Okay, we're pretty much gonna do that. We're gonna verify if the middle name is as expected. Here we can say it's like, hey, I want you to expect that. What's going to check is now the property, which is, as you can see, is way much more straightforward. Say person that middle name, okay, is to equal in terms of values of the Louis, right? Of Louis, and that test passed. So what you're actually checking is that actually does what it's supposed to do, right? You're checking is from the user story perspective. Hey, it create now the first, middle, and last name. Hey, it's doing all of this. Next task is this. We'll throw if you provide an empty string. Okay. So it wrapped this into a function, and this is something interesting. Because here is when we need to check an error here. Verify that function about throws. So we can use this as a throw error, okay, where it says you must wrap the code in a function, otherwise the error will not be caught and test will fail. So you must wrap this into a function, that's right, and then to throw error here. And then to throw error here. So this must throw is, and then we say, hey, I want you to, once you create an empty person, I want you to expect to throw is, which is, I expect that the function here to throw this error, right? That's it. I don't expect you anything else. And actually it throw as expected, right? Because for example, if we say, hey, Joe, that actually doesn't throw as you mentioned, right? Person will throw if you provide an empty string. It's actually not providing an empty string, and that's what happened, right? So far so good. Okay. The other is the to do here. Will throw a specific error if you provide an empty string. Okay. Full name cannot be in an empty string. Interesting. This is more like for exactly. This is more like for verify if that actually throw with the aforementioned error. What you got is this, so counts here. Let's go. Now that you define is the setup as well as the functionality, the next one is the expectation here, which is, hey, I expect that this function, especially when you're gonna throw an error, to throw error, okay, with this message, right, which is in this case error message. And there you got it, right? Full name cannot be an empty string. If you take a look now at this, there is a particular way of how you can handle that, like that. full name cannot be an empty string. There you got it. And the similar for the other particularity tests, right? So you guys will add a friend. They already actually provide that. We'll add a friend. Okay, so let's go to verify is now this contains Paul, which is now that I want to check this particular text, we'll say, hey, we'll add a friend here with person and Paul, we define that, and then I'm going to add a friend, which must be an instance of a person. Then I expect, right? I expect this. I expect that John. I expect that this object, John dot friends, okay, that collections to contain is Paul, that instance, right? If you run that, actually is checking as expected. Hey, I want you to now is verified in this collection you have now this object here. So if to do will mutate, will mutually add a friend. Okay, so now it's also going to okay, it's mutually add that friend to that. And this is a unique. Okay, and that particular reference of the friend, I want you to now add this object that I create here. That's quite interesting. That's very, very interesting. So you say now things like John, Paul, that kind of thing. I expect this to say, hey, I expect now that Paul dot friends, right, contain is the John. Interesting. So you are actually linking is that object that you are receiving with this new instance friend and vice versa. Okay, you will remove a friend. Pretty self-explanatory, you know. You can say in this case is like, hey, I don't expect to have here, I don't expect in John friends not to contain is in this case not a string, is an instance of Paul, right? And that actually passes expected. Similar for John, because it's actually mutually remove that. Interesting. We're gonna also check if that doesn't exist here. We say, hey, I want to expect that Paul, exactly Paul you can say, hey, I want to check now if Paul I want to check if now Paul on friends to not contain, to be contained, to contain, okay, is John and vice versa. Okay, and vice versa, right? I want you to now John friends not contain is Paul, right? When you run this, actually it mutually excludes that. Counts explode here. Something went terribly wrong. It should throw an error of explode. Oh, exactly. Because the absence of test is a success, but when you explode that, exactly. So that this test must fail. Alright, and similar to this, should throw on a specific error containing terribly wrong. So it should fail when you check now is, or you can write is this, something like, hey, I want you to now de-explode. I'm going to set up the function here. We're gonna now is the error. Okay. Since this is now throwing an error, objects here, an error. Okay. So now error is a type of error. Okay. And then what we're gonna do, expect that this error dot message, okay, to match, because I want to check if a string there, if this contain is terribly wrong. We can define our setup function here, say message of terribly wrong, okay, and use this message here as a way to do this, right? It say, hey, it fails. Oh, because it throw an error. That's right. Exactly, because it throw an error. It's an explosion throw a specific error containing this. Exactly. So you can say, hey, it fails, but as you can see, you are not actually is verifying is that. So what you can do here, because we are returning is a function here, you can say, hey, well, because it's returning a function and this is the message that we want to check, I want to look at this function and say, hey, from the error, which is a function, I want you to now is verify this, right? You to now is verify to throw error, okay, to throw an error that contain is that. It's a should throw an error containing a terribly wrong. It's a explode. That's going to say, hey, good. Let me now run this and wrap them into a function. That's what happened. That's what happened. Error function. Okay. Where in this case we're gonna do something like this. Error function. Okay. And I want you to now check that. Right? And actually is checking that work as expected. You can use it failed as a way to say, hey, it fails. Or you can now wrap them into a function, especially if you want to throw an error from a function, and then verify that, right? Hey, terribly wrong. So it's pretty straightforward. this particular test as a way of how you can write your tests, synchronous tests, which to me is quite interesting. And that'll be all for this video. Take care. Bye bye.